Hello and welcome to today's webinar, How to Build a Lightning-Fast Multi-Petabyte Backup Repository. This event is brought to you in partnership with Quest and produced by Actual Tech Media. Thank you so much for joining us on the event today. We've got a great event lined up for you. Before we get into it, just a few things that you should know about today's webinar. My name is David Davis of Actual Tech Media, and I'll be serving as your moderator. We at Actual Tech Media, we always want these to be educational events for the audience. We're all former IT professionals ourselves, and we know how tough it can be in the world of enterprise IT. And so we want to help to solve your technology challenges. And so we encourage your questions in the questions box. We'll be doing a dedicated Q&A session at the end of the webinar today, so get your questions in early. There's always a lot of questions on these events, and we also, of course, encourage that with our best question, Amazon $50 gift card, which I'll talk about in just a moment. We also have a number of resources there in the handouts tab for you to check out. First off is the link to the Quest Netvault Plus solution. We'll be discussing that solution during the webinar today. And then second is a link to the white paper on how to build a lightning-fast multi-petabyte backup repository, of which this event is based on. So, just make sure that you download that white paper and, check it out after the event, because it won't be as easily accessible as it is right now. And then finally, at the end of the webinar today on the live event, we'll be announcing the winner of our Amazon $300 gift card prize. That prize, of course, is not available if you're watching this on demand, and prize winners must submit an IRS Form W-9 to Actual Tech Media. The prize terms and conditions can be found there in the handouts tab. And I mentioned our best question prize for an Amazon $50 gift card. Questions submitted will be entered into that prize drawing that will be announced after the webinar. Now, before I introduce you to today's expert presenter, just a few things I'd like to chat about to kind of set the stage for today's topic. I know enterprises out there that I talk to are facing a lot of challenges. I mean, there's challenges, kind of across the board, but one of the biggest challenges that companies are facing is protecting their data. We have to protect our data from ransomware and, security breaches, and of course, accidental deletion, which surprisingly is, still one of the most common causes of data loss. But the challenge here is that traditional backup solutions, just aren't going to cut it with the massively scaling data sets that I know so many companies are dealing with out there. Companies just expect their data storage to scale indefinitely. And along with that, we need to scale our backup repository indefinitely, and then also keep that backup repository not only on site, but off premises, have multiple copies of it. And so for that reason, the backup repository has to just scale indefinitely and infinitely with the data set. So that's a huge challenge for us to deal with, and traditional solutions just aren't going to cut it. Recovery is also expected to be almost immediate. If you ask any executive out there how quickly they would like their data back if it's lost, well, the answer is going to be, immediate. I want it back immediately. And if you ask them, about the RPO, how much data are you willing to lose? The answer is most likely going to be none. So, of course, that's a different conversation when, to go down to try to weigh the pros and cons of RPO and RTO and costs and technology. But the expectation here is, especially with ransomware events, that we need to be able to do a mass restore of all of the data, almost immediately or very quickly. And that's been the real catch with a lot of these ransomware events, is that they are infected with ransomware at a very large scale, and they need to get their data back, and they have the data, but they aren't able to get it back quickly enough, and they end up having to pay the ransom just to try to unlock their data, when unfortunately they had the data already, but they simply couldn't get it back in a timely manner for the business or the organization to continue. And then fully redundant. As I said, the data should be rapidly available, and it really doesn't matter the scale of the disaster. So the offsite data set needs to be fully redundant with the on-premises data set, again, multiple copies, and then finally, highly secure. That backup repository must not be infected or breached with ransomware. The data must not be stolen. It needs to be highly secure. And these are, in my mind, the top challenges that IT organizations are facing out there when it comes to protecting their enterprise data. Now, to talk about the solutions, and one of the best solutions on the market today, I'm excited to introduce you to our expert presenter. That is Mr. Adrian Moyer, technology strategist in the CTO office at Quest. Adrian, it's great to have you on the event today.
Great to be here, David. Thanks for having me.
Absolutely, yeah. Take it away. Tell us about the Quest data solution and how it can help to solve some of these challenges.
All right, so let's move into that straight away. So one of the big challenges you mentioned a little bit earlier, David, was about the kind of the data growth thing, and this kind of gets laboured on quite a bit in our area a lot, and it is something that is continuing. And when we kind of look at where we've been on this kind of journey, most of the data we see, when we went from megabytes to gigabytes, and now we talk around petabytes, and we've got customers now that are on the verge of actually having an exabyte of data. Now, that was kind of unheard of unless you go back to the 90s. An exabyte was the name of a tape library, if you recall those. And it's not slowing down. The last couple of years has put more data in than the previous 10. And we're seeing this kind of growth. It's very much a non-linear growth. So it's kind of a rapid curve growing up. And you can see where we are now in 2021. We're like 70 zettabytes is what we're at now. And kind of quite interestingly, there are two more words beyond a zettabyte. So the next one is actually called a brontobyte, which is 1,000 zettabytes. So dinosaur-sized kind of data sets spring to mind. And then there's another one beyond that called a geopbyte, which I haven't actually seen written out anywhere, but one assumes it's 1,000 brontobytes, which is 1,000 zettabytes. It's a huge amount of data. But will we get there sooner rather than later? If we carry on at the same rate, probably. It doesn't seem to slow down. And this is the issue we have. It's about being able to move all of this data to have those copies you were talking about, and being able to move it from point A to point B as fast as physics will allow, because that's what we want to do, and be able to get it done quickly enough that it doesn't interrupt with production and it doesn't upset other people. And then you've got to have another copy of it, so you've got to move it all again, and you want to have that second copy somewhere off-site, usually at a minimum. So you've got an awful lot of data to move around in a very short space of time. And usually what happens when we get these problems, we end up thinking about, well, okay, so what can we do with this? How do we keep pace with this? So we look at the kind of the major backup technologies that kind of help to deal with this one. There's a very, obvious one that springs to mind. And this was kind of driven a bit more around kind of like the whole point of moving to the next phase was the necessity of it all as the data grows. And as we all know, necessity is the mother of invention. So you get to this point now of thinking, okay, well, what's the technology that's going to help out? And the first one that springs to mind is deduplication. Now, deduplication, people talk about quite a lot these days, and it's almost become a ubiquitous requirement for a solution that's going to actually protect data. Although sometimes they don't actually tell you exactly what the deduplication is going to bring you. And there are different types as well, different ways of doing it and different outcomes. If we wanted to kind of drive a little bit deeper into that deduplication methodology, there's a few things that kind of spring to mind. And what we first look at is, let's see how this kind of helps. So if I take a set of data that I have to protect, let's call it our first full backup of data, you have to start somewhere. And this is where it already starts. Now, most IT shops and admins are already probably doing this to a certain extent, so they're kind of already there. But if you're looking at leveraging deduplication, there's a few things you ought to know that they're not always created equal. So if we take a set of data, and I've just used some simple letters here to define some data sets. Now, in this particular backup, you can already see that there's a bit of redundant data there. There's two A's. So really, I don't want to store two A's. That would be wasteful. So you may get some deduplication out of the first backup data set you store onto a solution that provides this technology. And then normally you think about doing some incremental change backups as well. It helps you move less data during the week, that kind of thing. So we take some incremental data. Now you may match some of these. You may find there are matches that the deduplication solution allows. And depending on that kind of deduplication technology, whether it's a block level or whether it's a file level, and also depending on whether the blocks can be changed to match better, will actually determine how much you're going to save going forward. So here we've got some blocks here that we are able to match. A and B, for example, I don't need to store those. I'll just store H, that's my unique data. And then I'm going to put pointers in to say that this incremental consisted of H, my unique data, and a copy of A and a copy of B. And again, this process carries on the next day or for how many days you're going to run your incrementals for. Again, we see some unique data being stored, and then we see some redundant data as well, putting some pointers in. Now you can carry on doing this. You can have incremental forever solutions, but they have a bit of a hiccup, is that if you have incremental forever and you're 6 months down the line and you want to restore everything back to a certain point in time, you have to make sure all of those incrementals are all there. If you lose one bit in the chain, then you start to have a bit of an issue. Now, to get around this problem, what we tend to do is to say, well, why don't we just do another full backup? It's like the reset button on the whole chain, and then you start with your incrementals again. Now, obviously, if you're going to do another full backup, you start to think, well, it's all this data all over again. It's going to consume all this storage. And this is where the deduplication technologies start to play into this really, really well. So if I was to do that same backup again with the same data set, and maybe it's changed a little bit as well. Maybe it's moved around since then, because we'd expect a level of change. So now if you look at the data sets that I'm actually going to back up this time, most of them I've already got because I've already had a full copy of data sets. I've got one bit of unique data. Now all of a sudden you see an instant saving. Now if you keep repeating this on a regular basis, this is one of the main things that drives the deduplication ratio that everybody wants to talk about. It's like the buzzword. It's like the megahertz of the CPU world that we had in the 90s, the race to be fastest. The deduplication ratio is the same kind of thing. Everybody wants to know how much they can save. And this is where it gets kind of interesting as well. With that deduplication ratio, it's born out of a few things. One, on how much data you're going to actually match, but also how long you keep the data for. The more data you keep, the more you match, the better the ratio gets. So it's not always about the data set. It's also about how long you keep it.
Adrian, I'm curious, there's a question here that came in. They're asking about deduplication ratios. I mean, what kind of dedupe rates do you typically see? Like what's a good one? What's not so good? And how do you know?
Well, so normally you'd expect the solution to be able to work that out, but you can take the data set, if you know its size, and see how much data space you've actually consumed. You divide one by the other and you get your ratio. But it does vary. There are certain sets of data that deduplicate really, really well. There are certain sets of data that don't. So good stuff is like virtual machines, because they've got operating systems that are all the same. They're all going to have the same blocks of data. They're all going to match really well. It's ideal. The other one is if you've got lots of databases with high churn rate, you get different data streams coming out from those. They don't match so well. Same with images. It's a little known one that if you open up a JPEG and if you resave it again without changing anything, it actually rewrites the data stream. So it's always different. So even though the picture looks the same, they actually don't deduplicate. So if you're looking at good deduplication ratios, it kind of varies a little bit, but I've seen at the worst end of the tree is like 2 to 1. And at the upper end of the tree, I've seen 89 to 1. Somewhere in the middle, the average ratios, you're going to be looking for around about sort of 15 to 20 would be realistic.
Okay, 15 to 20, is for average, sounds great to me. That could save you a huge amount of storage space in your backup repository. There's a few other questions that came in about when you talk about deduplication, what type of deduplication are you referring to? Is it source side? Is it global?
There are many words around this. So if you think about deduplication as data comes to the target, there's two elements there. One is a post process where the data has to land on a disk, and then it's picked up, and then it's processed and stored. Then there's inline, where the data hits the box, and that's the data stream is actually processed in real time, in line as it were, and then stored straight away. If we then look at source side deduplication, that's where you have a little bit of software that intercepts the data stream, and it makes a request to the target to say, have you got this block of data that matches this? And if it returns a yes, it says, okay, I'm not going to send the block, but put a pointer in. So you end up reducing over the wire data sets. And that's kind of good if you want to have more throughput, or if you want to send stuff over a WAN link. That helps a lot there.
Excellent. Yeah. Thank you for clarifying that.
No problem. So one thing we can look at then is to think about scaling this out. As David was saying, you get to this point where you've got to think about how you're going to deal with all of this data in an easier fashion. And then scaling out becomes the next big question. How do I achieve this scale out thing? And there are a few things to watch for as well when you get to the point of thinking about how you're going to make this happen. And there's a few things that we can look at around kind of some techniques, but there are a few trade-offs to think about as well. And there's a kind of a three-way, like a triangular trade-off. There's a risk associated with some of them, there's storage usage issues, and there's manageability. Now, there isn't a holy grail here in as much as finding exactly right. There's always going to be a little bit of trade-off, but there are ways of making it as best as you can do. We'll go and look through some of these as we go forward. But there's, looking at this from a load balancing point of view, if I had lots of deduplication instances running, I can look at it, okay, which is the least busy at the moment, send the data over there. Then there's the what people say global deduplication. Now, there's a couple of areas around that. People will talk about global deduplication. They mean all of the data that actually hits the target. And then there's a global deduplication across multiple targets and how that works. So there's two things to bear in mind there about spreading data around. Then there's another one I like to call data determined deduplication as well, which is a bit kind of smarter than the previous two. And we'll look at all three of these as we go through. And the other thing as well that kind of comes in, I saw we had a question about this as well around the kind of incremental forever pieces, but creating a new full backup based on the data you already hold, which is something we call a synthetic backup. So that kind of, hopefully that answers your question, Amin, that you put forward there. So synthetic backups is a way of looking what you have stored from the previous full, looking at all of the incremental data set you have, and then creating a new backup set from that. And we're going to look at that too as another element that can help you when you're into larger data sets, when you don't want to shift all that data around again. You can be smarter about utilizing some technology that actually kind of helps you move forward.
And I'm curious, Adrian, is incremental forever and a synthetic, is that the same thing, or are those different things?
Well, so they're kind of a combination. So the incremental forever idea has been around quite a long time, and it goes from the idea of saying, I don't want to do a full backup. Once I've done one, I want to take data sets out and move them forward forever and just pull smaller bits. The synthetic piece is when you want to say, I want to push that full backup reset button, but I don't want to do a full backup. So they kind of come hand in hand to be a bit more intelligent about creating that next recovery point, so you don't have this huge long chain of incrementals that you have to get recovered.
Interesting. Yeah, I mean, because if you do an incremental forever, and when you go to restore, you don't want to have to forever being restoring incrementals. But you're saying that's not how it works.
It's not, no, and we'll go into how that synthetic full works a little bit later as well. So we'll dive into that a bit more.
Excellent.
I have there's a little question that's coming in from Jonathan here. What block size are you using for dedupe? That's a great question. The solution we actually use is a variable block size, so we can actually slide. It's like a window you slide around, and it enables us to actually match the block size based on the data type and get the best match of ones and zeros to whatever else we have stored. So it actually allows us to be more agile, make better savings, rather than actually having a fixed block where you have data that runs over that boundary and doesn't match. So it's a variable one. All right, so let's move on. Let's have a look at some of these kind of different techniques that are available to us. So let's look at the first one. So this is what we would call class as a load balanced deduplication. So the idea is that you have a group set up with a target of technologies that you're going to send your data to. Now, these targets are your deduplication systems. And the idea is you have a pool of storage that you want to send these to. Now, you can send this based on a kind of a load-based solution. And in this instance, the one there slightly to the middle right, 10% is its load. So the backup goes there. And here we have our data set that gets stored on there. Now, if I backed up the same data again, but when I got to that point in time, a different box in our target group had the least load, well, then that data is going to go there. Now, it may well be exactly the same data. Now, you start to see here a little bit of an inefficiency about how much data we have stored. So we've now got twice the amount of data. It's exactly the same. So it's not really a great use of my data sets when I'm working with a load balanced solution. It's not overly efficient in that way. So if I then think about having maybe the fulls and the incrementals, I've got maybe another full backup sat here, and because it's load balanced, I've put the incremental has ended up on another solution. So now I've got a chain of backups here, and if you think about that incremental forever scenario, they could be spread pretty much anywhere. So now if I lose one of these boxes in my pool, I've now got effectively a redundant chain of backup data set. Because I've had one box failure, it's affected data set that's spread across more than one. So now I have a problem that, I've only lost one machine, but it's effectively killed the data across two, and I can't recover that data set now. It's kind of gone. So I then have to go and think about, okay, well, if that's gone, what do I need to go and back up now to put that back in place? And it becomes really kind of quite hard to manage when you have this kind of outage. And, if it all falls away, then away goes our data. So let's think about the next solution. Let's move on from the load balancing. Let's think about deduplicating the data set across all of those boxes. So think about, rather than sending it all to one location, it's just saying, I'm going to break it up and I'm going to spread it across for this huge amount of throughput, which sounds really good. You'll be able to get a lot of data through there really quite quickly. And if you add in things like source side deduplication, it's really going to lift the whole thing up. So now you think, great, now I'm working at scale. But there's a little issue with this. As you can see here, my data set for my full backup is spread across my 6 systems. Now, obviously, you've just seen from the previous slide where we lost one box. If I lost one box out of here, I lose my entire backup because the stream is no longer there anymore. It's gone. So what do we do around this? So what actually happens in these kind of solutions is they make another copy of the unique blocks. Now I've just done kind of like a round robin here, shifted to the right by one, so that my data is now available in other locations, which is fine, which is great. But of course, now you're using twice the amount of storage that you really want to. The whole kind of point about a deduplication system is reducing that storage footprint. So it's a compromise. And I did say we were going to come across some compromises in this, right? This is being a bit more risk averse. So when we have this situation, that's fine. It's just going to use more storage, but it gives me a little bit more resilience to a point. So if I lose this box, for example, and all those unique data sets disappear, So I've got BH, G, and D. They've all disappeared. So now my deduplication namespace has to think about, well, hang on a minute, I've now got stuff now that's only got one copy of it. So I'm now, a little bit more at risk. So if it's a self-healing solution, it's then going to start thinking, okay, well, I now need to think about making copies of that singular data set. So it starts doing its own shift to the right by one, which is fine. But if you now look at that box that's in the middle of that set of 3 on the right-hand side, it's getting rather full. And this is the situation you can be, careful of here, is that if you start having failures and you start having to move more and more data blocks and content around, it starts to fill up the other boxes. So you start to actually give yourself another problem. And if you were close to the edge anyway, you're going to have a real problem with it actually becoming an issue that you've only got then singular unique data spread across multiple boxes. You lose another one and you're going to be in real problems. So again, it's kind of compromised a little bit. So let's look at our last solution. And what I think is a bit more elegant is to look at something being, and as Jonathan points out, yes, you also have potential performance issues in your dedupe namespace. You're absolutely correct. And so let's look at something else, something I call data-determined deduplication. And it works in a slightly different way. And it relies on the fact that your target pool technology that sends your data to all of your devices is intelligent. So here I've got sets of data. I've got 3 different data sets here on 3 different devices. Now, what you really kind of want to get to is to think about what data it is that I'm sending, and then send it to the place it was last. And that means you're going to get the best kind of match. You're going to get the best out of your deduplication. You're going to be able to reduce the storage footprint. And if you're still using technologies like source-side deduplication, you're still going to get that throughput availability. So it starts to become something a little bit more intelligent and reducing, that real kind of aspect. So I don't have to store all of that data because I've managed to dedupe it intelligently. So let's run through the whole risk piece again, same as before. If I lose a system, what happens? What's the outcome? Well, I'm just going to lose the backups of that particular data set that went to that device. And because it's only been that data set and only that data set that's been stored there, that's the only one I've got to go and redo again. So none of the others are impacted at all. So, okay, I don't have my risk compromised now as much. And there's another extra piece you can get out of this solution. If you think of the others, we've talked to this quite a bit actually, David, around the whole synthetic full piece. If you think about doing load balanced, or if you think about doing global deduplication namespaces, if you consider you want to do a synthetic full backup, you've got to go and read the full backup and all the incrementals and create a new full backup. Now, you can do that through the backup software, which means it's got to read it all up, write it all down again. It's not very performant. You really want to be able to do that at the storage layer. But when your data is spread across these load balanced or this global namespace solutions, it's all over the place. So you've now got to have another layer that thinks about what it has to go and get to find and move to create this new unique synthetic full backup. And then if it's a global piece, I've then got to go and make another copy of all those unique pieces again. So it starts to become really, really complex and really very, very, very hard to manage. If you're looking at it from a different point of view, though, if you think about having this as an intelligent set of data that's only targeted for where it should exist, that synthetic full becomes an awful lot easier to do, because the targeting is done from where the data has come from as opposed to the type of data. So that brings us kind of round to a little bit to think about solving this solution and how we go about getting this solution together so it drives all of the outcomes that you want to have. An intelligent methodology of storing data sets. You want to have a way of reducing the whole full backup thing with large amounts of data. we've talked a little bit, about that synthetic fault. So let's look at how we deliver this in Quest as a solution. So we have a solution available on the marketplace called Netvault Plus. Netvault has the ability to back up physical machines, virtual machines, lots of databases, and it allows you to have multiple different types of hypervisor, from VMware to Nutanix and Hyper-V and Red Hat Enterprise virtualization too. And we utilize a deduplication technology we have called CoreStore, which comes part of the Netvault Plus package. And the two are tightly integrated so that we can actually sit here and create this scale-out repository. And it's one of those things when people say to me in this solution, how many of these repositories can you create and store? And so this is the nice thing about this. It's an odd thing that we normally say in IT when we say, yeah, you can have lots of them. It's an infinite number. Now, obviously, we'll never get to being infinite because, well, that's an esoteric outcome. But there is no limit to the number of CoreStore instances or targets that you can have inside that scale-out storage pool. So I can take some data here from the yellow machines. So I've got 3 instances. Maybe they're a bunch of virtual machines coming through a proxy off a set of hosts. It doesn't really matter. What Netvault will do is it will remember where the data's come from, and it will remember where it sent the data to. And we'd have a different set of data coming from a different set of machines, a different set of data again from another set of machines, physical, virtual, it doesn't really matter. And it remembers where it's come from, and it's going to remember where it's going to go to. So always the yellow and the green and the blue data sets always go to the same CoreStore instances. So we intelligently manage where the data lands. So you're going to get the best deduplication out of this. You're going to minimize that risk by not spreading it around. So if one box does fail, you know exactly which systems are affected by that straight away. And Netvault will tell you that. So now I've got this ability to scale out an infinitely large pool of storage with this technology called CoreStore. Now, CoreStore is kind of neat because it's a software-defined solution. You can run it on your hardware. It's not an appliance, so you can actually go and choose what kind of hardware you want. You can run it in a virtual machine as well. You can either have a pre-built virtual machine, or we also supply an installable that you can go and actually run the installation and build your own technology. You can also run this in cloud. And one of the interesting things about running in cloud is that CoreStore, for its storage, for its backend, can also leverage object storage. So you don't have the expense of managed disks or SSD at the back end to store all your secondary data sets. So you can use the cheapest cloud storage mechanism, deduplicate your data, compress it, and encrypt it before it gets to that object storage. So it is fully optimized and secure up in the cloud. You can replicate between CoreStore instances too. So if you have an on-premises data set, then you can replicate that up to a CoreStore instance in cloud. If you're in cloud and you want to go to a different cloud provider, you can do that. Quite popular at the moment is our Microsoft 365 technology. People are backing up the data in one tenant, and they've got CoreStore running in a different tenant somewhere else, and it gives you, a level of separation for your backup data as well. So we can be really kind of agile because it's all software defined. So now we think about, we've got our data in place. So let's think about those questions that were popping up around about the synthetic fault piece and the incremental forever that we've discussed. Solving that problem of getting all of that backup data. So how do we do that? So let's think about this. I'm protecting some data. I'm sending it using our in-house protocol, which is called Rapid Data Access. This is a non-standard protocol. It's not a broadcasted protocol. It's a secure data movement as well. We have a technology called Secure Connect that wraps up the data set as well. We also provide source-side deduplication here too. So whether it's physical machines or virtual machines, you get true source-side deduplication coming out of your infrastructure, and the data goes directly to the storage target. It doesn't go through a backup server. It doesn't need a media server. So it's direct to target technology. So I do my first full backup, which is what we'd all expect to do. I then follow that on with a whole set of incrementals, as you'd all expect to do. Now, this is where we get into that whole incremental forever. Great idea, small amounts of data every day, or we're down to these days, people want it every hour or every 15 minutes. So you're taking all of this incremental data, it's smaller amounts, easier to move, got source site deduplication, doesn't do much across the wire at all, it's really good. Okay, I now need to push that reset button because that incremental chain is getting a little bit long. I want to now create another full backup, but I don't want to drag all of that data over the wire again. Now, source side deduplication helps if you do that. However, there's a smarter way. And this is where having that intelligent scale-out storage solution really comes into its own. Because of my yellow, green, and blue data, the yellow data, we'll use that as an example, is stored on one instance. I've got all the full and all the incrementals because we've remembered where it's come from. So now if I want to do my synthetic full backup, what we do is that the Netvault solution goes and talks to the relevant core store server and says, hey, this full, these incrementals, I want you to go and create synthetic full, and it's all done at the storage layer. So the synthetic full is all called, so it just takes a few minutes to create. We've got most of the data, it's creating mostly pointers, and that's it, it's done. So we now solve two of our issues. We've got the storage layer worked out. We've now got a scalable pool, source side dedupe, very efficient. We've got storage savings, very efficient. We've now got our synthetic full, which is also now very efficient. So now we've got this ability to create this huge multi-petabyte solution that's highly efficient in data movement, highly efficient in data management, and all managed through a single interface as well. So you don't have to hop out to one interface to another or this one or that one. It's all done through the Netvault interface. So it provides a very simple and easy route to actually solve that wider, larger data solution. All right, so that's got us to the end of that piece around the technology set. Do we have any other questions, David?
Absolutely, yeah. We've got a lot of great questions coming in. I want to remind everyone about our best question prize. We'll be selecting the prize winner from those who submit their questions after the event. So let's see. There's a lot of questions. Where to start? First one: how does the data from the protected resource get into the core store pool? Does this use agents? Is it agentless? How does that work?
Well, agents or agentless depends on how you want to deploy Netvault. If you've got physical machines, we'll put an agent on there and we can be application aware too. If you've got virtual infrastructure, we can do that agentlessly as well. So depending on how you want to scale your virtual infrastructure, you can utilize one proxy. If you take VMware as a good example, you can have maybe 10 hosts. You could put one proxy for all 10, or you could put 10 proxies across there, and we give you a consolidated view, and it then chooses which is the best host to move the data from, and then selects obviously the target. So we kind of automate that too. So both agentless or agent based.
Excellent. That's cool. I like that flexibility. I do want to go ahead and bring now up our poll question that we like to run at the end of these events, just to see who would like additional information. I've just brought the poll up. If you haven't done one of these before, you answer it right there on the screen. And it's a multi-select question, so feel free to select more than one answer if you'd like just a data sheet, or if you'd like a personal demo, or try out an evaluation of this for yourself. So another question that came in, I know we talked about the synthetic versus full a little bit, but can you kind of just explain to us one more time, what's the difference between a synthetic and then just taking incrementals? Because I think that's an important point.
Yeah, sure. So the synthetic full gives you sets you another recovery point as a baseline, if you think of it like that. So if I did full backup at the first of the month, and I wanted to then do incremental forever, and I did that for 6 months every day, then I've got all of those pieces, those little bits of backup in that chain. Now, if you lose one little bit in that chain, then the whole chain is null and void. You can't recover anything. So to get around this kind of situation, if I did maybe a full backup at the first of the month, and then I do incrementals throughout the month, and then at the last day of the month, instead of me carrying on and doing more incrementals and creating my problem, I hit that reset button and I create a synthetic full. Now, what that does is then the following incrementals changes are then based off of that synthetic full. So in effect, all you're doing is carrying on pulling data from your systems in an incremental way. So the data pull is still incremental forever. It's just that you've got better control about when you want to recover, because you can recover back to that from that synthetic full that you created and then the incremental. So it's less data for you to sort through when you're recovering.
Got it. Okay. Thank you for clarifying that. That's important.
You're welcome.
Someone out there said they didn't see the poll. If you don't see the poll on your screen, just push refresh on your web browser, and 99% of the time that will resolve it. Here's a good question that came in from Amin, I believe is how you pronounce it. He's asking, what about failover cloud backup replication, and can you use the backup for cluster recovery?
Yes, you can. If you want to replicate data sets out to the cloud, you can do that. The replication can happen between core store instances. So there's two ways of getting your data to the cloud. You can either have a pure replication copy, which is like a one-to-one, and have everything stored up in the cloud. You spin up a core store instance, leverage the object storage in cloud to get you best bang for buck, as it were, and you can replicate data. The other way is to extend the core store instances with cloud tiering. So it's like using cloud storage as an extension to those core store instances. And then it's driven by a policy inside core store. It's transparent to the backup solution, and it moves data across to the cloud for you. When you want to recover that data as well, what we do is we look at the recovery request that's coming from the backup software, and we go and look at the dedupe map. We pull any blocks that we have locally first before we start pulling from the cloud. So it reduces your egress costs too. And also that first byte to recovery is a lot quicker. So yes, there's two ways of getting data to the cloud. If you want to move that data up, pure replication or extension, we can do both. And if you're into long-term regulatory, we also support AWS Glacier and Deep Glacier as well. And it's direct. We don't hop to S3 first on the way out. So it saves that cost too.
Very nice. Yeah, that savings could be significant. So that's a cool feature there. Another question here from Jeff. He said, when it comes to the recovery or the restore, does that happen in a virtual space? And where is that space used, remotely or on-prem?
Interesting question. If you're doing a restore process and you're putting your data back, we can put it directly back to either the host system where it's come from, or if it's a bunch of virtual machines, you could put it back to a different host if you so wished. So it's flexible. You can even restore things like SQL databases as files. So you don't, if your SQL database server's not there anymore, we can recover that as a bunch of files and you can send it somewhere else, or we could recover it to an alternate SQL server. So it doesn't happen in a virtual space. It's literally straight back to where you need it straight away. So speeding that recovery is what David was saying earlier about getting data back as quickly as possible. We'll put it back into the application for you, rather than you having to, you're given a database file and I've got to go and open up a tool to actually go and put that in. So things like Oracle, for example, if your Oracle DBA is away or sick and you've got to restore an Oracle database, Netvault is easy in as much as getting that data back for you. So you don't have to be a DBA to understand it. It does all the hard work for you. So it kind of simplifies that, and it will drop it straight back to that Oracle server that you're looking for.
I like that, because a lot of the folks that do the backups and manage the backup infrastructure aren't always, database or application savvy, perhaps. And, you want to feel like you can get things back up and running without having to call for help from DBAs to do it. So very cool. Here's an interesting question from Aldwin, who says, what if the first full backup was corrupted? Is there a solution to mitigate that? Is there some way to test the backups to know that they're valid?
Yeah, a couple of ways actually. There is a little checkbox in our solution that says, check that please. Some solutions don't verify their rights. We do. Netvault doesn't only obviously support CoreStore, but we also support lots of tape libraries and other solutions too. So we have to have a way to make sure that our data rights are verifiable. So that's kind of built into the solution. So we don't have that issue around corruption, or at least to my knowledge, having worked with the system for many years, corruption is very low on our radar. And the CoreStore technology, there's 10 years of R&D into that, and every instance of that technology we've ever deployed has never had a single data loss for a customer through corruption. So again, I'm going to touch another piece. It's actually melamine in my workshop that I'm touching now, but it's close enough to wood.
Nice. It's good to know. That's good to know. I like the idea of a checkbox as well.
Yeah.
Another question, Ernesto's asking, how is the solution licensed? What's the model around that?
Great question, Ernesto. I noticed you put up, space or endpoint. You could do either. We're flexible on the licensing. We either do front-end terabyte, so how much data you want to protect. You can make as many copies as you like. You can replicate it wherever you like. Or if you've got a large set of data but a small number of machines, well, we'll say actually it's more applicable if you want to just have it done as a node-based solution. So we can do either. We're flexible like that. Having said that, the most popular is via the front-end capacity piece, because it's so easy. It covers everything. You get all the toys, and away you go.
I like that. And that way you don't have to worry about, oh, well, I added a new client. Do I have a license for that? You just buy the capacity and you get as many clients as you want. So
that's it. And you can be as flexible as you like.
Excellent. There's another question here about encryption. Does this offer encryption at rest, and will that impact performance?
Good question again. Encryption is very important to us. We do encryption at rest. We also do encryption in flight too. So the data stream is wrapped up with that secure connect technology. But encryption at rest, we do that after we've done the dedupe and after we've done the compression. And what we do is we hold off the encryption while the system is busy. And then when it's quieter, we then start encrypting stuff. So it doesn't impact the performance. What is kind of cool, though, there is two elements around our encryption technology. One is a very easy passphrase-driven AES 256-bit. The other one, you can actually utilize a rotating key. Now, this is where it kind of gets interesting. It's actually a patented technology. We go and use a unique block of data that the system chooses itself to actually perform the encryption with. So it's a no-knowledge encryption piece. And every 7 days or so, or every 10 days, depending on what you set, you can actually get it to go and use a different block of data for that. So that means every 7 days, the new incoming data is encrypted in a different way. So if somebody was trying to brute force stuff out of there, they're going to do the first bit maybe, and then, oh, hang on a minute, I've got to do it all over again. So it becomes very, very difficult. So encryption at rest doesn't impact performance.
Excellent. Next question that came in, they're asking about, this one's from David. If you pull the data from the backup, is it immediately deployable, or does it need to go through some validation or configuration? How long would it typically take to get, let's say, a virtual machine back up and running with this solution?
Straight into VMware, and as soon as it's finished back recovering the data, turn it on. There's even another little checkbox that says, do you want us to turn the VM on after we've recovered it? It's straight away. It doesn't need to be validated because we've done that on the data ingestion. So things like database checksumming we can do during the backup, so we know the data is verifiable on the restore. So things like a database, put it straight back into SQL. Again, we can say, go and attach and spin it up, makes it available as soon as the restore is done.
Nice. I like that. What about restore options? Recovery options. We talked about recovering a VM, and I know we can recover files. What about block-based storage?
It depends on what you're doing with the block-based storage and what's on top of there. So, for example, there there are solutions that we hook into at the storage layer where we trigger snapshots at the storage layer, if that's what you mean by that kind of block level piece. So we would trigger the storage snapshot. We can then recover the storage snapshot. We can also then mount the storage snapshot and move the data off somewhere else and recover it as files or folders, for example.
Excellent. And I know you talked about recovering a database, how easy that would be. So is it safe to say this is application aware?
Very much so. So Oracle is that good example. We actually interface with RMAN. It's the technology we have for Oracle is really, really, really good. I mean, it's kind of class leading. So we have all those kind of RMAN options that you can use. You can even, if your DBA doesn't want to use the UI, for example, he can actually create RMAN scripts and then use Netvault as the transport mechanism to go and save and store data. And then the backup administrator still gets a view of that too. So there's lots of ways around doing that. So yes, application aware, very much so, for things like SQL and the likes. One we often get asked about is MySQL. There's two variants out there. There's obviously the free one and there's the paid one from Oracle now. The paid one, we can actually do a live backup of a MySQL database. So you don't have to put it into a read-only mode at that point either. So depending on the data set and the kind of technology you're backing up, if we can do it in a way that's fully application aware, that allows that kind of live backup piece, we will do that. Otherwise, if not, then usually some of the lower databases, they have to go to read-only mode, and then you do the backup and then pop them to a write mode. So it's all dependent on the data, but by and large, yeah, application aware, very much so.
Excellent. All right. So many great questions coming in. Everyone, don't forget about the poll question on the screen. I like this one from Nicole, who's asking if the backups need to be done outside of production or working hours, or if we did the backups during production hours, would it slow down the applications?
Well, so that's a great question, and an awful lot does actually depend on the host system you're running the application on, right? A lot of people I've had over the years say, "Oh, my backup's slow. This device is slow," and it's actually being throttled by the machine you're pulling the data from. There are lots of technologies around that. For example, Microsoft's VSS snapshot-based technology that works with things like Exchange and SQL and file systems were designed to prevent this kind of thing. Now, if you tie that up with the source-side deduplication technology we have with this solution, you're sending less data over the wire, so you're not flooding the network interface on that machine that the application is running on, whether it's physical or virtual. So that kind of reduces the impact a lot. I mean, you usually get like a 3 to 5% uplift in CPU, but that's much more amenable than actually not being able to have the solution available at all during that backup time. So you can kind of pick and choose depending on the ability of your solutions. Things like virtual machines doing snapshots quite quick. It creates a difference disk in VMware, for example, and it carries on working while we do this. Usually when you want to do that at scale, the biggest impact is on the storage and not so much on the application. So again, it's one of these things that you kind of have to balance. So you can do it in production hours, you can do it outside of that. It depends on what you want to get out of that outcome. A lot of people do balance it. Some will say, well, we can do these in production hours because it doesn't have so much of an impact, but the other ones we have to do outside of working hours. So you can make the best of the daytime and the nighttime, depending on what it is you're protecting.
Excellent. Where does CoreStore run? Is this run on premises or just in the cloud? How does that work?
So CoreStore is an installable solution. So you can run it on premises, you can run it in a virtual machine, you can run it on a dedicated piece of hardware, you can run it in a machine in cloud as well if you so wish. So it's pretty much wherever you want to install it. I would say to get the best out of it, you want it as near to the data as possible. You don't want to be throwing terabytes of data over a WAN link. Obviously, eventually the deduplication piece kind of helps with replication and source side deduplication, but the first backups, it's going to take you a while. So just consider where your data is and where your data's got to move to kind of make the best use of the physics that we have to deal with to get that around. But essentially, CoreStore can be installed and run pretty much wherever you want.
Nice. I like that flexibility. And then back to one of the points that I made at the start of the event, that the backup repository must never be breached by ransomware. When we talk
Mhm.
about ransomware, is the backup repository, secure? Could it potentially become infected?
Um, I would say everything can be potentially become infected, but CoreStore is pretty secure. It runs on Linux for a start, so that kind of reduces its threat vectors a little bit.
Yeah.
Um, and also the protocol we use, the Rapid Data Access Protocol, is non-standard. It doesn't broadcast, so actually getting to it's pretty hard. The access is done through another authentication method between the backup software and CoreStore, and that's a separate authentication to anything else in terms of logins. So you can make that really quite obscure. So access to it is pretty much tied down. What I will say in a forthcoming release that's up next, we're adding even more technology around that to harden it up even further. So expect a bit more on that coming out from us soon.
Nice, nice. And then what's the difference between NetVault and NetVault Plus?
Good question. Netvault and Netvault Plus. So Netvault is the backup software. So if you just wanted to change your backup software and go and want to work with Netvault, you can go and buy that. And if you've already got a backup target set that we integrate with, that's fine. Netvault Plus allows you to have the Netvault backup software and the CoreStore all purchased as a single item. It's a really easy way of actually looking at it, and you can say, I need 20 terabytes of Netvault Plus, and I'm done. That's it. So really kind of straightforward, and you get all of the technology. Everything's included with the technology sets if you buy that kind of capacity piece, and especially with CoreStore, we include all of the replication technologies and all of the encryption technologies. There's nothing extra. The cloud tier capability is 3 times the installed license, so that's no more extra to pay for that kind of license. The same with using the archive tier out to Glacier. That's included inside CoreStore too. And obviously, if you've got a different backup solution you don't want to change, CoreStore works with 13 backup solutions. So you can leverage CoreStore and all its great technology to further push out your solution too.
Oh, excellent. I like that. I like that option there. If you have a solution you already like and want to keep it, then this can step in and solve the scalability problem that I know a lot of companies have.
Yeah. Yeah,
And
it'll
then
just make whatever you have better, is what we normally say.
that's right. That's right. Let's see. We're running out of time here for questions. Maybe just a couple more. They're asking about the restoration of data and the RTO. Are there any statistics in terms of the time that it would take, or estimating the time? Like, I guess the question really is, how do you know you're going to be able to meet your RTO?
Well, that's a really good question. It's not many people actually ask that kind of thing. So well done. That often gets missed when people think about recovering and building a service level agreement with the business. It's kind of hard to work out. There are some technologies we're actually kind of working on at the moment to actually say the recovery time objective is likely to be this. What we do is actually give you a view of how much data that you've been protecting for each data set, and we get estimated backup times. So if you kind of think about the time it was to estimate to get the data there, it's going to be very similar to get the data back again. So it gives you a kind of a view to that. So as you kind of go along with the solution, you'll start to learn about how long it's taking to move your data around. The likelihood is that's going to be a really great indicator around the kind of recovery time objectives you're going to get with the size of data. So, and everybody's different as well. So it's kind of hard to have statistics on that. Infrastructure varies so widely, it's hard to pin it down to a single thing.
Okay, excellent. Well, so how does this work? How should people get started if they want to try this out for themselves? Is there a free trial?
Yeah, there is a free trial. You can download the technology available. You can pop there. I think if you pop back one slide from the poll, we'll see. I think it's under the QA question. Let's see if we can get to that. There you go. Quest.com/NetVault Plus. If you hop to that site, you will be able to get all the information you need. You'll be able to download trials. The trials work fully functional as well. And the CoreStore piece, if you like CoreStore, then that also comes with a 1 terabyte storage usage. It's community edition, free for life. you can go and do whatever you want with that. But yes, it's all available, all free to download. Get it up and running, try it out, and you'll be well on your way to solving your problems.
Excellent. And for convenience, I put that link there in the Handouts tab. If anyone wants to just click that on the top of the Handouts tab, it will open a new web browser tab or window. So make sure that you check that out. Also, check out the PDF download that's also on the Handouts tab, how to build a lightning fast multi-petabyte backup repository. It's a great resource. And with that, I'm afraid that we are out of time on the event today. Adrian, thank you so much for your excellent presentation and all the education that you gave us today around data protection and disaster recovery.
You're more than welcome. It's been great to be here. Thanks, David.
And thank you to Quest for supporting today's event. I learned a lot. I hope that everyone out there did as well. Visit quest.com/netvault for more information on this topic. And then finally, I'll announce the winner of our Amazon $300 gift card. That is going out to Jason Bowman from Massachusetts. Congratulations. We'll reach out to deliver that prize. Thank you, everyone, for joining us on the webinar today. We'll see you next time. Bye-bye.